Hello guys and welcome back. Today we're going to be unpacking a very interesting topic behind Twitter recommendation algorithm. We're going to be doing more than what you can typically find on the web in those high-level articles for marketers and influencers, with the only point being how to game this system to get more views. I'm going to be touching on that, but what brought me here in the first place is my boundless curiosity of what is it that algorithm is doing so that I get the feed the way it looks. To answer that question, we're going to look into the system from two perspectives. What matters for the users is either content creation or content consumption, or is it a healthy balance of both? Users can be after views, so the algorithm will be ordering a specific behavior, or they can be seeking for relevance in information they're receiving, so the algorithm is trying to give them that. Or is it so? To give you the most comprehensive answer, I did my best at analyzing all available sources, including technical documentation, scientific papers, and even source code that was revealed in March last year. To get us started, I want to bring this picture to outline a typical user experience. As a user, you spend most of your time in the For You feed that has become a default view since a couple of years ago. So in there, you scroll through the infinite feed in a search for the engaging content. You scroll past some content that is no interest for you, whereas you engage with other content that you find fascinating by liking it, following external links, or participating in conversations. So you're giving the system signals of the stuff that you like, and it takes it into consideration to feed you similar things in the future in turn. There is another feed called Following, and that is where you see the tweets from the people you directly follow. It's been there since the very early days of Twitter. That's how they started its so-called in-network circle. Then they extended that with additional tweets from all of the platform and brought it in a form of this modern For You feed. They feed you the tweets with the highest probability that you will most likely engage with in some way or form. They calculate the probability of you engaging with a tweet based on some statistical analysis and machine learning methods of your activities and activities of the people that you engage with. There is some serious data science involved, which we'll look into in some of the papers they released. It all sounds good and fancy, but the system is going to be as accurate as how much data you're going to give it to work with, or in other words, how much time you're spending on the app. It's sort of like a double-edged sword, can work both for you and against you depending on your purpose there. I'm doing this deep analysis to show you what's really happening under the hood of Twitter or virtually any other social media platform, to be honest. What's data being collected and produced, what's being processed and how it's processed, how it's correlated with other data of other users. So for you to stay conscious about the decisions you make on the app and how much time you spend there. We're gonna start with an official article, Twitter's recommendation algorithm, that was released on March 31st, 2023, along with source code and some technical documentation. This article, by the way, was analyzed like thousands of times back then, straight away by curious minds, YouTubers, bloggers, with the only point to figure if there is a way to game a system to get more views of sorts. But that is simply not what we're here for, okay guys? Though you can derive this knowledge from my presentation and analysis, but I want to focus solely on engineering aspects of it. So what Twitter wanted to do back in the days, and I gotta apologize Elon Musk for not calling it X, though I think X is a cool new brand name. The reason being is that the Twitter has existed for virtually 15 years and they've built a lot of stuff internally, and now when it's released, like every single doc refers to it as Twitter and it's all over the place. It just makes sense to call it this way for consistency reasons. Back in the days, they were aiming to answer two most important questions that were relevant to virtually any social network, to be honest. So first is, what is the probability of a user interacting with another user in the future based on some historical data? And another one, what are the communities arranged in a natural way without members explicitly organizing them themselves? They've built a couple of systems and organized them into the pipelines that determine data flow that consist of 3 stages. In the first one, they select candidates amongst the entire pool of tweets on the platform, appropriate for particular users based on some statistical methods we'll get into. They rank selected tweets from multiple sources, obviously. They apply heuristics and filters on the finish line and then finally feed it to the user. They source candidate tweets from two major pools, in-network and out-of-network sources. And as they claim, the distribution is roughly divided by half amongst them, though it varies from user to user. And just to give you an example of this exception, if a user, say, doesn't follow a lot of other users who don't stay active on the platform, so they're not much stuff coming from them. So in that case, it will be skewed towards this out-of-network pool. In-network and out-of-network candidate source algorithms differ in nature. So it's like a completely different thing running behind the scene in either case, selecting candidates for you correspondingly. So it can really influence the system, give you better, proper recommendations by just adding or removing people from your circle. The system that powers in-network source is called RealGraph, and that predicts the likelihood of engagement between two users. It's using this whole logistic regression model that heavily relies on historical activities of a particular user proportionate to the activities of the rest of the users you follow. In the case of out-of-network, things are more complicated. Here, they're making use of multiple things, essentially. For historical reasons, they've preserved this system called social graph, the whole point of which is to derive some sense out of your second-degree connections by traversing the graph of engagement activities between them and your first-degree connections to find the strongest ones and feed it to you too to see if it resonates with you. It's still serving about 15% of all home tweets. They're also happy with this new thing known as Embedding Spaces in the data science community. They've built SimClusters, which is a system that detects 145,000 communities amongst all of the activities on the platform, coming from both content consumers and content producers. Turns out there are methods for both groups. Those are implicit communities. You can't see them. You can't tell how many people are in there, and it's changing over time. But the reason they're happy with that, because after introducing this system for candidate sources, they started to see a considerable growth in engagement metrics. But the candidate sources by themselves aren't going to give you the feed. You gotta sort them out first and put them in proper order. And for that, they're using this ranking system based on neural network that gets continuously trained on your data, on activities from all the users on the platform, and it gets optimized for positive engagement that gets translated to the time you spend on the app, essentially. That is why social media recommendation systems, or in other words, feeds, are so addictive. They wouldn't be doing good if they didn't do this. That's beyond any neural network or statistical method. They obviously want to honor your opinion and respect your preferences, so they will hide undesirable content from accounts that you block or put on mute. They respect author diversity and content balance, so you're not going to be seeing a lot of stuff coming from a single person, even if they're working relentlessly, like printing it out of the press. There is such a thing as fatigue, that the feedback that you give someone degrades over time, giving them a chance to engage with you again. There's such a thing as social proof that puts up some safeguards and protects you from low quality second degree connections by making sure that the first degree connection has engaged with them, and a couple of more things for a greater good. Once they filter out unnecessary stuff and put the rest of it in a proper order, they mix it up with some ads, some follow recommendations and onboarding prompts, and finally serve it to you. And they also do a great job at reprocessing it very many times during the day. And now we're gonna have a look into the promised repository that contains a lot of interesting data points, though not everything. They turned out to remove a couple of essential pieces, but luckily for us, leaving some important code and documentation that's gonna give us a good picture. And here we are, the system design of their thing that powers a recommendation engine. It contains the most important pieces in the process, though not everything. We're gonna touch on a couple more. But here how they show it here, okay? Starts with data. Data gathering, data ingestion. As you know, nothing can be done without data. The more data, the better. They extract some features out of the data using various statistical methods, and we'll look into those later. They feed these features to their other systems to prepare candidate sources, okay? And there are a couple of them for different purposes. For search, for tweet recommendations, for people recommendations who you want to follow, okay? They take these clean data through the neural network, they call it heavy ranker, to give it a rank, to basically sort it out based on the highest probability or engagement activities you're going to do, right? They apply some heuristics and filtering rules as we discussed, and they mix it up with ads and with other things to finally feed you in the timeline. We're gonna have a look into the first paper now, and that is their GraphJet graph processing engine that maintains a real-time bipartite interaction graph between users and tweets. This paper, in fact, outlines the evolution of graph recommendation systems over time, all built in-house from scratch and iterating over the improvements of each other. The purpose of this whole thing is to keep an engagement of the user base by suggesting new connections between users and between users and content. The two important vectors around graph recommendation systems that they'd been laser focused are graphs themselves, derived from various contextual signals and user behavior of such, and an ability to process the graph in real time. GraphJet is essentially a storage engine for graphs, the entire entity of which can be held in memory on a single machine. They provide with a simple API, which they claim is very efficient because they power it with efficient algorithms in the backend that leverage concurrent lookup queries with dynamic memory allocation. Fast forward to the data model and API just to have an idea. So this is a bipartite graph with users represented on the left-hand side and tweets represented on the right-hand side, with edges representing their interactions over time. The API is indeed simple, represented by 5 different methods for edge insertion and for edge traversals in both ways. What may spark an interest for us is the recommendation system that is built on top of it, and that is represented by 3 available algorithms that downstream systems can leverage. Those are full salsa, subgraph salsa, and similarity. The first one is a typical random walk around their bipartite interaction graph back and forth multiple times with a growing probability to stop and restart. They initiate this walk from the query user, or if that hasn't been active in a while, they'll pick someone from his circle of trust. And the output of this algorithm is going to be the vertices on the right hand side, which represent the recommended tweets. Another one is kind of the same thing, but done on the portion of that graph, restricting the algorithm to just neighbors of that initial seed. Still relevant for some social proof scenarios, and it benefits from the performance standpoint, usually fitting into the cache memory. Lastly, the similarity algorithm I find the most fascinating because it can tell what are the most similar set of tweets or users based on engagement activity of the other group. And they do that by random walking similar to the first 2 algorithms across the graph and calculating cosine similarity between 2 vertices every time, and then compare it with each other to give it a rank in the output. The deployment architecture is trivial, just a bunch of GraphJet servers, a single instance of which with at least 30 gigabytes of memory, being able to hold a graph with a size of 10 to the 9th edges. There's a zookeeper cluster keeping an eye on all those servers and providing with service discovery for the clients. And there's a Kafka queues on the left, ingesting user tweet events to GraphJet servers. Because of a simple design, this thing is very resilient and highly scalable. An individual such server can support up to 500 recommendation requests per second with low latency. And they also proved the consistency to be above 4 nines in terms of requests across all users. The next on our list is this RealGraph paper, the system which we already slightly touched on in the previous paper. But I want to specifically focus your attention on this one because it contains a couple important points and mechanics outlined that have preserved relevance up to this day, because the system still powers this following feed with in-network connections. What the system does, or rather is a framework to compute relationship strength between users. In it, users are nodes of the graph with directed edges connecting users one to another, estimating a probability of this engagement in the future. What's important is the graph generation itself, which is based on a couple of points when one user follows another or interacted with them in the past. It also includes this corner case when one user has a contact of another in his phone book and has given the app permission to use it. The algorithm takes into account a couple of things, for instance, how often users interact with each other, how long ago was the most recent interaction, and the strength of each interaction sort of like decays over time. The number of common friends is also involved, and a couple more things. They attach some user features to the edges, such things as amount of activity, number of tweets, followers, things of that matter. And then they train the logistic regression model periodically, daily, to score real graph edges, to derive weights on the edges. So it becomes a binary classification problem with a task trying to learn what combination of features in a certain period can predict whether there'll be a similar interaction on the same edge in the future. They were also able to evaluate the results by splitting features into multiple groups and computing the area under curve, representing some sort of algorithm effectiveness. And they ended up with this picture with an address book being the most effective predictor of user engagement. The next system we're gonna review is a big deal because that's where they source the most recommendations from at the moment for the main feed. It is the most recent as well. It was deployed in 2020 and have been showing great results ever since in terms of engagement metrics of such. And let's see what it's built of. They're starting from outlining the overall recommendation problem by underlining the importance of taking into consideration multiple targets that are subject for recommendation that the previous systems didn't quite do. So in their proposal, they are suggesting to take these targets behind another abstraction called communities and treat them heterogeneous. The idea is to build a general purpose representation of a community from the user graph with vectors in the space representing those recommendation targets we just saw in the table that characterize the strength, or rather an interest, of a particular community in a specific target. Let me outline a couple of design requirements that will greatly characterize the existing system. Firstly, it's universal, and that means that it's representative of both users and different types of content. It's capable of handling high-scale systems such as Twitter. It's accurate enough and beyond just the most popular content. It adjusts to dynamic items changing in popularity rapidly. It's interpretable, and that translates to the system being able to maintaining inverted indexes for various representations to efficiently retrieve nearest neighbors that applies to various tasks. Now, how do they do that? Well, essentially, it's a two-stage process consisting of community discovery and computing representation of those recommendation targets affiliated with the communities. The simplest way to understand this community discovery algorithm is just by walking through this technical documentation in the repository. The step number one is to represent in a bipartite graph both consumers and producers that translate to followers and followees correspondingly, with each user being able to be on both sides at the same time. Then they translate that to a producer-producer similarity graph by computing the cosine similarity between users who follow each producer. Then they apply this metropolis hastings algorithm to determine a fixed number of communities in the form of a matrix with values representing the strength of affiliation of a particular producer with a certain community. In the second stage, they calculate representations of various items and user groups, or I should rather say affiliation strength with various communities. And they do that for consumers, for producers, and for various items here. One interesting aspect about this system is that its parts are different in computational complexity, so they treat them differently. They separate them out to compute with different frequency and by different computing clusters and reuse the results for the downstream stages. Now, what do they use this for? Well, for a number of things. For starters, they look for similar tweets. There is a module available that shows you recommendations in various notifications. These days, there is a button under each tweet that shows you some similar tweets, apparently, that I guess is powered by this thing. So prior to this, what they did is they show you recommendations from people who share a lot of followers with the author. And now you're basically seeing the tweets, they have high cosine similarity with the original tweet. They ran this experiment and found out that it actually increases the engagement rate by 25%. Secondly, it's essentially a replacement for the prior system, GraphJet, that we've reviewed already, that powers out-of-network tweets. They also ran an experiment for that one and were quite happy with the 33% of the engagement rate. And the way they replace one system with another is not like they shut down the old system once a new one is available to take the full responsibility. No. They take it gradually, they control the number of candidate sources sent to the downstream system, and they measure the engagement rate or some other metrics, how the overall system performs. And if it performs better, they decrease the number of sources from the old system in favor of the new one. Essentially, they use it for everything. They rank trends, topic, and who to follow recommendations, and everything has shown better engagement rates. Our next paper we're gonna review was released less than 2 years ago, and as such represents one of the most recent works in the area of social media recommendation systems. They describe the system that has been deployed at the Twitter scale, tested and evaluated with some very promising results we're gonna dig into, and as such is of a big value for us to go through. The point that they're addressing here is what makes a good recommendation, and that to their experience is various interactions from multiple relation types a particular user is experiencing on the platform with the rest of the system on a daily basis. That, as they say, includes and encodes valuable information about social network and should be taken into account in the recommendation model. They are outlining the importance of using large pre-trained embedding tables in recommender systems and providing with industry examples of well-known vendors that have successfully adopted this method in their various use cases. There are a couple of arguments they make towards using a rich diversity of relations between entities, and they are: first, data supplementation. That is when there is not enough data points about a particular relation, but there is a need to make a recommendation. Say you're not hitting advertisement links too often, but someone from your circle of trust in fact hits the links quite often and you engage with them somehow. Well, they can supplement these relations into a denser form, and by that they can improve predictive ability of embeddings. And secondly, task reusability. That comes from universality of representations, allowing you to reuse embeddings for downstream tasks without needing to retrain the model. So what does the system represent is a heterogeneous information network with different types of entities and various relations between them. The entities can be things like user, tweet, advertiser, and ad, with relations like user favorites one tweet or follows another user or clicks this advertisement link. Further in the paper, they present this algorithm, the purpose of which to extract information from that network through large-scale embedding, and then they finally infer multiple embeddings through clustering for each user and tweet for the downstream tasks. The way they do that is they represent each entity and each edge type as an embedding vector, and they assign a scoring function with parameters that characterize that vector, and they train the model at 6 parameters that maximize the likelihood that the result of the scoring function is going to belong to a particular edge. To the point of sparser relations, the way they address it is they form two heterogeneous networks with high coverage relations, such as follow graph and user tweet engagement graph, and then they augment that with low coverage relations with entities such as promoted tweets, advertisers, and promoted mobile apps. Then they compute multimodal embeddings based on inferred vectors to take into account various interests users might have, and also release from a retraining to support any novel out of vocabulary nodes. The way they transform user embeddings into multimodal mixtures of embeddings is through introducing clusters over targets that are representative of different types of relations, and then associating each user with a probability distribution over elements of a cluster proportional to the amount of engagement the user has with each cluster. This is a picture of an overall framework showing how everything is glued together in the process, starting with constructing a heterogeneous information network graph based on information from the outside sources in various databases. They infer the embeddings thereafter, calculating multimodal embeddings for the matter, and then they use it for downstream tasks such as ranking and candidate generation. In the results that they've published for candidate generation tasks, they've received considerable gains and improvements in recall when using mixture of embeddings over the unimodal approach. They've also done it for advertisement ranking and discovered that it gave them an average of 2.38 relative cross entropy gain over the baseline. This is the way how they measure model quality, and that in turn resulted in an over 10% cost per conversion reduction in the new production model. Now, when we've reviewed all of the papers, let's go back to the system design to see where we are at. So far, we've covered these 4 systems that derive various features from the input data and provide it to the downstream services through the set of various APIs for candidate sourcing and recommendations. There are a couple more systems down here, though they don't represent much of an interest for the sake of this discussion, so I'll just give you a slight idea what are they about. The first one just simply calculates a user's influence over other users based on their interactions with them, or the amount of interactions. It works similar to the Google's PageRank algorithm in the old days, where more links leading to a page would mean a better page reputation and a higher rank in a search page. There are better algorithms available today, and as such, I don't think that this algorithm still remains relevant and has been substituted by other systems by now. The other one is a set of models that they've trained on a lot of text and visual data with the purpose to detect and exclude inappropriate content, incorporating adult and sexual topics and violating Twitter's terms of service. This brings us to candidate sources that are representative of various recommendation modules across the app. The first one is search index, and that powers search itself apparently, and half of in-network tweets you're receiving in the feed. The second one, so-called CR Mixer, is a candidate generation service, the purpose of which is to retrieve candidates from the upstream services we've discussed and feed it to the downstream services for various reasons, particularly to empower this mechanism to fill in the out-of-network feed. The third one is completely empowered by GraphJet and provides with notifications that someone from your circle has liked a particular tweet that you might be interested in as well. The last one is follow recommendation service, and that what gives various recommendations of users who to follow, which you can find in various places in the user interface. But let's go into the heavy ranker, because that plays a significant role in calculating the score across all of the candidate tweets to establish an order in which they're going to be fed to the user, if ever at all. At this point, candidate tweets go through the inference process of the model that has been trained on a bunch of features to optimize for the highest probability that the user will engage with the tweet in a certain way. Now let's go see all of the features that the model has been trained on to estimate those probabilities. If we scroll through this long document, we'll see a bunch of feature names that are representative of a particular system where they're coming from. For instance, this group of features are sourced from SimClusters, which we've already covered. Another group is a subject for retrieval from the Earlybird search system. Sometimes you can see features that would just mean typical properties on a tweet, such as whether one has a media or a text of a particular length. And sometimes you can find some timeline or engagement metrics for the matter. And those are aggregated over a particular metric for various time spans for the model output accuracy. Once you take the data through the model, it's trying to predict whether the user is going to take certain action against a similar tweet. And those actions are somewhat hilarious in some cases. There are a few normal ones involving a user liking tweet or retweeting or replying tweet, but some of them, for instance this one, estimates the probability of user opening up the conversation and spending at least 2 minutes there, right? There is another one, the user pulls up the video and watches at least half of it. Right. To calculate this score, they apply certain weights to those probabilities and then add them up all together so that it's a single number representative of a score for a particular tweet. And that will majorly influence the position of a tweet in the feed of a particular user. And remember, the heavy ranker, as the name suggests, is a heavy machine learning model that needs to be trained periodically on a lot of data. We've just reviewed a whole bunch of features that require to be collected from the upstream systems and aggregated over time. The data point of those systems also have a notion of relevance. I haven't found information anywhere on the web, but training of this model is most likely not a real-time process. Similar to the stage first of the SimClusters algorithm, it's most likely a very heavy batch operation that is scheduled to be done on a high-performance computing cluster every so often. So don't be surprised next time if and when you adjust your behavior on the app, you only start seeing the results on the following day, if not later. They also have Earlybird light ranker that powers recommendations for in-network tweets and search results, I would say. But as they write here, this is an old part of the stack and currently being redesigned and replaced, so we're not gonna spend much time here. After the tweets get through the machine learning model, and that is nothing but assigning a label to them with a relevance score, and before they get into the mixing element for the output, they have to go through the series of heuristics and filtering rules to make sure that the final feed looks the way it's supposed to. That is done through applying discrete methods in the end over the statistical machine learning methods for better guarantees. The best way to see how the home mixer is composed and some functional aspects of it is through the source code, in fact. What you want to do for that is to have a look into the product package of the home mixer service of their repository. And here you can see multiple packages representative of various business functions that are behind certain visual elements in the app that you're dealing with on a daily basis. We're gonna review a few of them, and that is for the feeds that we are experiencing almost all the time when we're using the app. If we compare pipeline compositions for the following and for you feeds, we'll see that they differ quite a bit in the structure. In the case of the following feed, the main source of candidates is this Earlybird system that heavily relies on the RealGraph and PageRank algorithms. Whereas in the case of the For You feed, the main source of candidates is a score tweets pipeline, which tells me that they're coming from the heavy ranker model. If we focus on the For You feed now, we'll see that there are a bunch of other sources, the candidates of which they're mixing in. There's one for people to follow. Sometimes you can see that widget in the middle of the feed. There's one for the ads. Of course, they're everywhere these days. There's one for conversation service, and that is to keep you engaged in a conversation you joined previously. And there's also one for edited tweets, which tells me that if someone edits their tweet, you'll see that again. Lower down the files, you see a bunch of rules that are applied to various candidate sources throughout the process that impose a certain behavior and restrictions so that the final feed looks a bit more natural. There is another interesting file that is sitting nearby in the same package that contains a set of parameters for different entities such as filters and pipelines. It can give you an idea what is more important and less important and how is it configured. For instance, this one defines the position of the widget of people to follow with a default value of 5, which is what I normally see when I get to the feed. This one defines some relation to ads with the default value of 35. No idea what that could mean. And the multiple numbers on the parameter tells me that they perhaps are using another external system to control the actual values in the runtime. The home mixer product file of the request package specifies all of the available products that are representative of the corresponding pipelines. And this is a way to connect pipelines, in fact. For instance, For You pipeline is sourcing candidates from the Score Tweets pipeline. And you can also see that in the Score Tweets product candidate source of the For You package. Whereas in the request transformer method, the product request is set to a Score Tweets product, which is the result of another pipeline. The way this scorer works is that it's using gRPC client to communicate with the heavy ranker prediction service. It iterates through the records of available candidate sources retrieved from other systems. It gets predictions on them using this client in form of various features. It calculates the weighted score similar to how we saw it in the docs, and finally stores all of that for further consumption down the pipeline. Interestingly, there's also a parameters file for the scorer containing all of the weights used in the final scoring function. But unfortunately, as I've been able to confirm, these parameters are in fact controlled externally using so-called config API service, the code of which they have forgotten to share with the world. I haven't been able to detect it in the entire Twitter org on GitHub. What also they've forgotten to share with the world is this timeline service, and I'm excluding a couple of things here in the search box that aren't relevant using regular expression. This is another name of it, and if you search through the repository, there's a bunch of import statements used all over the place, pointing to various clients for data retrieval from external systems. You can see things like Manhattan Search Prediction Service, SimClusters. All of it is in there. And if you search a little bit more broadly, you can see that the config API is in fact a part of it. And what we have in the bottom is that they also have various specifications of feature aggregates. So what I think this timeline service is something that they use internally to make the final adjustments to the algorithm every so often. I believe that it makes direct effect to the final feed composition and not on the individual user by user basis, but rather holistically from the entire user base perspective. So what I think they do with these parameters is that they experiment a lot to find the optimal configuration point where an average user engagement is the maximum amongst all of the users on the platform. Alright guys, it's been a very long journey, 40 minutes long. I know I'm tracking myself, a very deep immersion in the Twitter's algorithm. It feels like it's the right time to draw the line and take away some learnings, but let me revisit what we've gone so far. We started with reviewing a typical user flow on the platform when interacting with the For You and the following feeds. We distinguished the two usage approaches for content consumption and content creation. We started with the original Twitter blog post about their recommendation system. We analyzed 4 scientific papers about most important and quite complex systems for candidate sourcing that play a big role in the recommendation process. We looked into the source code repository for available documentation, walked through the README pages, and made sense out of the business portion of codebase that defines product pipelines responsible for processing the tweets for the final output in the For You feed. So for mindful content consumption, and what do I mean by mindful, is not going after the trends, but make it rather useful for you. For that, first, you gotta understand that the system has been highly optimized for maximum engagement from inside out. Everything you do on the app matters. Though individually your actions may matter more than the others, collectively and across the feed, they will point in the same direction. We know that the system tries to differentiate multiple communities, and we know that the number of such communities is limited. What you probably don't know is that some communities are bigger than the others and as such more influential. What that means is that if and when you start getting some content from the more influential community, it'll simply overshadow the less influential one without even you realizing that. And that's gonna happen because you will unconsciously pay more attention to more engaging content from the bigger community. If you want to remain control of your feed, you gotta be very disciplined. You have to prevent yourself from engaging with any form of undesirable content if you don't want to give a system a wrong but the powerful signal. You definitely want to follow the right people, the content of which you find interesting, and not just a single message 1 out of 10. It has to be virtually everything, at least 90% of it that they put out there. Interestingly enough, but the algorithm doesn't make use of semantic similarity or what we know about it by GPTs or LLMs. I'm not talking about search or this novel grok experience. What the algorithm does is that it's looking for the pattern and trying to associate you with one of them. As I said, the algorithm is very sensitive, especially to the trends. They don't adjust against the popularity, and as a result, it's shooting like crazy when it's hot. So you have to be very explicit to show the algorithm what you really mean in taking some extra steps to adjust for it. For instance, you want to like useful content, like really useful content, but you don't want to like just interesting content. You don't want to scroll a lot, but instead use conversations more thoroughly. Just to tell the algorithm, this is what I really like, so give me more of that. You do want to make use of filters to hide undesirable content, but you also want to make sure that you use it continuously, because there's such a thing as fatigue. That means that the feedback you've given degrades over time. And remember, the heavy ranker model parameters are adjusted not just for you, but for everybody. Even though they're using a big model with 48 million parameters, it is not enough to cover everybody's unique situation. And of course, you're being watched all the time whenever you are on the platform. Every single thing you do, every single place you stare at is being recorded. And if you haven't opted out of it, they will try to correlate this information with ad providers. And for practical content creation, and what I mean by practical is not attacking users with your content. Please don't. By practical, I mean engaging with people, exchanging messages in a meaningful conversation and not trying to sell them stuff. You can teach them something, or you can learn something useful from them. You want to make sure that you engage continuously on top of just creating the content, perhaps doing some activity in conversations, probably with the same people, because algorithm is gonna honor that. We know that the number of communities that they differentiate is a fixed number, which equals 145,000, and that's it. Given the total population of Twitter of 500 million, it gives you on average 3,500 people per community. But we also know that a single person could belong to multiple communities, which is normal. What it tells you though, that people with less than 3,500 followers probably aren't going to be treated by the system well. So what you want to do in this case is that you want to find people with at least 3,500 followers, but not much more than that. So you're not after popularity and the competition remains low, okay? Limited to 5,000, let's say. But you also want to make sure that the content they're producing resonates with you to the extent that you want to do it yourself. Once you find those people, you're gonna want to replicate them, but not in a bad sense. Don't get me wrong. You want to add value to what they're already doing out there, but do it in a similar manner. The system treats media quite positively because it resonates with people and takes a larger space in the feed. So you want to make sure to include a picture of sorts with the right ratio and such, but not a video, because I don't think Twitter is a place where people watch videos a lot. For the same reason as the videos, external links take attention away out of the various engagement activities. But external links are even worse than that, because they take a person off of the platform, diminishing their engagement metrics in your favor, so that they will less likely spot your content in the future. And a couple of well-known things that you might have seen somewhere else in various high-level articles. You gotta pay for the blue check mark because it matters. It's explicitly set in source code. As long as you have it, the algorithm is giving you the boost. You don't want to use inappropriate language anywhere at all in your posts, in replies. Everything is taken into consideration when calculating a score for your post. And the most important thing you need to think about is how to make people engage with you, with content you create on the platform. That's all I have for you guys for today. I hope it's been useful and insightful. Trust me, a lot of effort has been put into it, but it's all worth it. I've learned a lot myself and I wanted to share with you. So don't forget to hit that like button, because this way you will have more, I promise. And on this exciting note, I want to thank you all, and I'll see you next time.